Okay, here we are again with section 5.4. So we've looked at graphing quadratic equations and they take a shape of a parabola. We've looked at getting the equation from either the graph of the parabola or a series of points. We've looked at the two different forms. We can get a bunch of information from both of them. Here they are, the general form being this, the C being the y-intercept. Okay, remember that the C is the y-intercept. The A and the A are the same. They give you the same information that tells you the shape. You can say if it opens up or down right away, if it's fat or skinny. This one we can factor to find the x-intercepts. Okay, we just talked about how we can find the y-intercept. Here, this one is more conducive to graphing because we can get the vertex right away from it, right? You can't remember, or you can't forget that the vertex is the H and the K here, okay? And the A gives you the shape. So what would be a very good tool would be to get from here to here. And before we do that, we have to understand a couple different things here. You have to remember how to FOIL, what the whole foiling process is, right? If I have x plus 3 squared, for example, okay? Well, that's the same as saying x plus 3 times x plus 3, right? Why did I choose x plus 3 squared? Because that's kind of what we have in here, okay? Now, when you FOIL this, you FOIL the first ones, you go the outside ones, then you go the inside, and you go the last. And then we simplify it by gathering our like terms. Now, what I need you to think about is how we get these two numbers. Okay? Understand that you multiply them, you multiply these two to get that, and you add them to get that. Okay? Now, what we're looking for here, folks, is we're going to be looking at something called completing the square. Okay? And we're going to be making perfect square trinomials, which is this. Okay? Now, just a bit of an aside here, if I gave you x squared plus 5x plus 6, right? You'd factor that into x plus 3 and x plus 2. You can absolutely factor that, and it even gives you the x-intercepts. You can even see that x is negative 3 and x is negative 2, so if you graphed it, it crosses there and it crosses there. You know it goes up like this somehow, but you don't have the vertex. It doesn't look like this because they're not the same binomials, okay? So we're looking at factoring, but we're looking at factoring perfect square trinomials, okay? So if I gave you an equation, if this was my function here, if I said y is equal to x squared plus 6x plus 9, you'd be able to say, oh, okay, that's x plus 3 all squared. And right now, you'd be able to tell me that my vertex is negative 3, and since there's no k value, it's 0, and you're done. Okay? But what would happen if it's not a perfect square trinomial? Okay, well, then that's what we're going to look at, okay? Before we move on with that, though, we have to know how to make these perfect squares. So x plus 8x plus what would give me a perfect square? Okay, so this is going to turn into something squared. This is going to turn into something squared, and this is going to turn into x plus or minus something squared. What number goes in here? Well, if you think about the FOILing process, right? Since it has to be a perfect square, it means that these two numbers have to be the same. So what two numbers are the same add up to 8, right? Basically, just take half of 8. And half of 8 is 4, right? And then, so that would be like having an x plus 4 and an x plus 4. That would give me the 8x. But what ends up going here? The 4 times the 4, which is 16. Which means that my perfect square trinomial will be x plus 4 all squared. Let's look at another one here. The process is exactly the same, okay? If you understand what's going on, great. If you don't, this is what you need to do. You take your middle number, you take half of it. Half of 6 is 3, square it, that's 9. There's your perfect square trinomial, and that means that it's x minus 3 all squared. How can you tell if it's a plus or a minus here? Well, that all depends on what you have here. If this is a plus, that's a plus. If that's a minus, that's a minus. Foil it out and have a look if you don't believe me, okay? Now let's look at another one before we get to the trickier one. How about x squared minus 12x? How would you finish that one off, right? So half of 12 is 6. 6 squared is 36. There you go. And so x minus 6 all squared is what that would be. Now we're going to get situations that are a little tougher. This is a perfect example. You can't take half of 7 easily. So what do? You call it 7 halves. That's half of 7. And that squared would equal 49 over 4. And that's what goes here, 49 over 4. The tricky part now would be to figure out what goes here. Now remember the process. Half it and then square it. Well, that point where you halved it is what goes in here. And there you go. That's your perfect square trinomial. Okay? Now, the next step would be looking at a situation where we don't have a perfect square. So for example, let's look at an equation here. If I had y is equal to x, x squared plus 10x plus 25, and asked you to put this in that standard form. Well, hopefully you'd see that you can simply just write it out as a perfect square trinomial. You'd be able to tell me your vertex is -5, and since there's no k value, it's -5 and 0. And then we can work it out from there. My question to you would be, what if I didn't have a perfect square? Say it was +7. That is now no longer a perfect square. So what do? Well, we take that 7 out and we put it over there. We save it for later. Okay? And then we go like this, plus a number. Now what's that number going to be? Well, half of 10 is 5. 5 squared is 25. The problem is we've just added 25 to this function. It's no longer the same. It's 25 bigger. So if we want to bring it back down to where it was, we have to subtract 25. I know that seems kind of redundant, but the whole idea is that we made a perfect square trinomial here. And so now we have x plus 5 all squared. And this minus 25 and plus 7 combine to give you -18. And you now have your perfect square trinomial, or your equation in standard form. You can find your vertex as being -5 and -18. Pretty basic, right? Let's have a look at another couple ones. If I gave you, let's have a look, y is equal to x squared minus 6x plus 2. Well, you look at that, you know, you might be able to factor it, you might not, but who really cares, because we know right away that it's not a perfect square trinomial. So what we do is we rewrite it. I take the 2 out, and this is, I do this every single time. I go plus a number, minus a number. Okay, because whatever you add, you have to subtract to maintain the equivalency. And now the process, what is it? Half of 6, 3. 3 squared is 9. You add 9, you subtract 9. The idea is that this now is your perfect square trinomial, x minus 3 squared. You combine these two numbers, -7, boom, there's your vertex at 3 and -7. Okay, now these will obviously become a little trickier. Okay, let's look at another one that might not have a nice round number in there. So y is equal to x squared, let's go plus 5x plus 4. There you go. Now, you could actually factor this, right? You could factor it into x plus 4 and x plus 1, but that doesn't really help me. I need a perfect square trinomial. So the process is this, same thing, x squared plus 5x plus a number minus a number plus 4 on the outside. Now, what's half of 5? Half of 5 is 5 halves. 5 halves squared is 25 over 4. So 25 over 4 is what goes here. Whatever you add, you have to subtract 25 over 4. The idea is that you get x plus 5 halves all squared. That middle point is what goes in there. And now we have to combine these. So we're minus 25 over 4 plus 4 over 1. So minus 25 over 4 plus 16 over 4, right? Gives me negative 9 quarters, so minus 9 quarters. And here is your final standard form, where your vertex is negative 5 halves and negative 9 quarters. A little more difficult to graph, but doable nonetheless. Okay, ladies and gentlemen? So now we're going to look at another situation where it gets a little bit funkier, okay? Because notice that in all these examples, I had a 1 here and a 1 here, okay? They're a little bit easier to do. What happens if I have a 2x squared? Let's go plus 8x minus 4. Actually, let's make that a different number. How about minus 3? Okay? Oh, let's make it a plus 3. What the hell? So now, I can't make this a perfect square trinomial, or it's definitely not a perfect square trinomial. So what we do is we remove that last term and we put it out there. We save it for later. The 2 here in front is a bit of an issue. We can't complete the square until we get rid of that 2. So what do? We factor it out. It leaves me with x squared plus 4x. And now, complete the square. Add a number, subtract a number. Notice that it's all inside the brackets. Half of 4 is 2. 2 squared is 4. Add 4, subtract 4. Now, we're almost done. This right here becomes x plus 2 all squared. This minus 4 needs to group with the minus 3. Can you see what has to happen to it first, though? Don't forget it's all inside the brackets, right? So that minus 4 has to get multiplied by the number out front here. So it becomes minus 8 plus 3, which is negative 5. Okay, that's the tricky part in these situations where you have the number in front. That number that you subtracted has to get multiplied by that 2 in there because it's essentially twice as big, right? It's inside the bracket. Let's try another one. Y is equal to, let's go negative 1/2 x squared plus 3x minus 1. Okay, well, that negative 1 is going to come out. So minus 1/2 x squared plus 3x. Let's go minus 1 out here. All right. You need to factor out whatever is in front of that x squared. So we'll factor out a negative 1/2. And this is the tricky part. What do you think that plus 3x is going to turn into? First of all, you should see that it's going to become a minus. And when you factor things out, you're essentially dividing by that greatest common factor. So 3 divided by 1/2 actually turns into 6. Okay? So plus a number, minus a number, and I got the minus 1 on the outside. Next step would be to complete the square. 1/2 of 6 is 3. 3 squared is 9, and 9. We're almost done. Negative 1/2. This inside the bracket. X minus 3 all squared. What happens to the 9 when it leaves? It has to get multiplied by negative 1/2. So it's plus 4 1/2. 4 1/2 minus 1 is plus 3 1/2. This is the final form of your equation, where you can see the vertex is 3 and 3 1/2. And then we can go about graphing it like we did before. Here we go, ladies and gentlemen. This is what we call completing the square.